Welcome to the Unit 6 Day 1 video where we are going to simplify radical expressions. Our goal today is, what is a radical expression mean? What does that mean? Make sure that you have your note sheet with you. They come in the big packet. Make sure you're turned to Unit 6 Day 1. It should read that on the top. And we'll begin. Let's review what we've learned in Unit 5 with exponents. 6 raised to the second exponent. 6 is the base that tells me what to multiply. 2 is the exponent that tells me how many times to multiply it. So this should be 6 times 6, which ends up being 36. So we say that 6 to the second power is 36. Now, in this case, the 2 exponent is on the 9 base, and the negative 1 is separate. This can be written as negative 1 times 9 times 9. Notice the base is not the entire negative 9. It's just the 9. So we end up getting negative 81. We'd say that 9 squared times negative 1 is negative 81. Now notice the parentheses, the grouping tells me that now I'm taking negative 14 to the second power. This is negative 14 times negative 14 that ends up getting a positive number. Now I don't remember what it is off the top of my head, and if you don't remember what your times tables are off the top of your head, you'll multiply the long way. I do not do lattice. I do the traditional method. So I do 4 times 4. That's 16. Now carry the 1 from the 16. It's actually 10. 4 times 1, or 4 times 10 is 40, plus the 10 is 50. So I have 56. 1 times 4, actually 10 times 4 is 40. 10 times 10 is 100. So I get 140. Therefore, I have 196. Oops. 196. Now, is this going to be positive or negative? Well, it's a negative times negative, so that makes it positive 196. So we say that negative 14 to the second power is 196. Now, Unit 6 is going to be going backwards from exponents. And what we will call these new items are radicals, or roots. You might have heard these as roots in your other math classes, like a square root. But we will be doing more than just square roots in this class. Radicals will answer the question, what times itself an index number of times equals the radicand? What's a radicand? Well, the index tells me basically how many times I need to multiply the number in order to get this 8. The radicand is what I'm taking the root of, or what the radical, what's inside the radical is going to be a radicand. And this radical symbol is basically the big part up here. So let me just outline this. The radical symbol is in purple, the index is the 3 in yellow, and the radicand is this 8. And the way that I would read this would be the third root of 8. And so basically I'm asking, in another way, what multiplied by itself 3 times. Now remember, 3 is the index. So what multiplied by itself 3 times equals 8? Well, let's answer that question. What times itself 3 times will equal 8? Blank times blank times blank 3 times should equal 8. What is it? It should be 2. 2 times 2 times 2 is 8. Let's look at square roots in more detail. When I say square roots, something squared means 2 is their exponent. And I'm asking myself, what times itself twice will get me 25? So basically, something times something gets me 25. Well, in this case, what can I factor 25 into if I wanted to split that up? 5 times 5. Okay, so I have 5 times 5, and this is a square root. So basically, I want to know what times itself twice will get me 25. Well, of course, the answer is 5. Here are the rules for if I want you to write something in simplest radical form. There should be no perfect squares in the radicand. Remember, the radicand is inside, so I can't leave 25 in there because 25 is 5 squared. Now notice the second root here, the index being 2. Oops, let me make my highlighter smaller. If my index is 2, and I have the radicand with a exponent of 2, the radical symbol, the 2 and the 2 will cross out, I just get 5. There should be no radicals in the denominator, and we'll talk about how to deal with this later. And there should be no fractions or decimal under the square root. So you can't leave it like this. Let's talk about a strategy to simplify square roots, and some of you might have done this before. The analogy I like to use is like this radical symbol, and the radicand is in jail, right? And in order to get out of jail, you need some help. Depending on how secure the jail is, how high the index is, that's how many people you need to break out of the prison. So for instance, if I had 4 and another 4 and a 2, since the 4s are both the same, 4 and 4, 4 times itself twice is 16. And if I take the square root of 16, these two 4s will break out of jail together. It takes 2 people to break out of this jail, and the 4 will escape, but his buddy won't make it. Only one of them can escape. This would be 4 times the square root of 2. The poor 2 over here by itself had a different base. There's only one of him, and he couldn't break out by himself. But the 4s, since they had 2 friends, were able to break out of the index 2 jail. But only one of them got out. Let's use our strategy to simplify the square root of 90. Now notice there is no index written here. If there's no index written there, you can assume we're talking about a square root, or something, the second root of 90. Okay? So in order to break out of this jail, I need to have 2 of the same base. Let's factor 90 now. What can 90 factor into? The one that most of my students will do is 9 times 10. You might have gotten something different. You might have did 3 times 30, and that's fine too. I'll show you what to do with 3 times 30 in just a moment. And now you notice there's a perfect square underneath there. 9 is 3 times 3. And I just keep factoring as much as I can. Notice that now I have 2 of the same guy in there. I have a 3 and another 3. And they're going to work together to break out of this 2-index radical. But only one of them will make it. And notice that 5 and 2 are different, so I'll leave those as 5 times 2 as 10. That will be my answer. Now notice I didn't write the 2 in the index here. You do not need to have the 2 on the square root. Now what happens if I would have factored it as 3 times 30? What if I had the square root of 3 times 30? Well, there's nobody that's the same yet, so we're going to keep factoring as much as we can. By factoring, I basically mean break up into its multiples. 30 breaks into, let's just play it hard. Let's do 15 times 2 instead of 3 times 10. And I'm just going to keep breaking things down because I still don't have any 2 buddies who are willing to help. But finally, when I factor out the 15, I end up getting the same factorization that I had over here. And of course, the 2 buddies here, the 3 and the 3, work together to break out of the 2-index jail. And now I have 3 times the square root of 10. Let's look at a bigger number, like 192. Let's factor it. Well, I'm not sure what goes into 192. I'm pretty sure that 2 does. Let's divide 192 by 2. 2 doesn't go into 1, but it does go into 19. 9 times. 2 times 9 is 18. That leaves me with 12. So I'll bring down this 2 from up here. 19 minus 18 is 1. 2 minus 0 is 2. 2 goes into 12, 6. So this is actually 2 times 96. I still don't have any buddies to help break out of jail. So I'm going to keep going. 2 times, and then 96 is even again 2. It's going to be 2 times 48. You have to trust me on this. I don't have time to go through all of this. And I can still factor. You want to factor as much as humanly possible. This is 16 times 3. You might start to recognize some of these. 16 is 4 times 4. And now you can see I have a couple of groups of friends who can help break out of jail. So I have the two 2's together that can work together, and I have the two 4's that can break together. I highlighted the wrong ones here. So they'll both break out of jail separately. So now, on the outside, these two 2's work together and only one goes outside. And now, the two 4's will also work together and that will go outside also. And inside, I still just have the 3. The poor 3 couldn't get out. There's nobody else to help him. What do I do with the 2 and the 4? Well, when they're inside the radical, they're all being multiplied. I'm going to multiply them again on the outside. So I have 8 times the square root of 3. And that's as far as I can simplify. Let's practice a little bit more. This becomes easier if you start to recognize some perfect squares. And what I mean by that, 1 squared is 1. And you should know your perfect squares up to at least 12. 2 squared, 4. 3 squared, 9. 4 squared, 16. If you need to, write these down on your homework sheets or on your worksheets just to help you remember all of the perfect squares you need to look for. Because if you can identify perfect squares right away, you'll be able to find pairs of friends who could break out of jail. In other words, you'll be able to find factors that are like, so you're able to divide 2 of them out. I'm going to stop at 100 just for time's sake. You could keep going. 11 times 11 is 121. 12 times 12 is 144. Now, what perfect square out of all these I've listed will divide 75 nicely? In other words, what will multiply to be 75? You should be thinking 25 times 3. And the reason I chose 25 specifically is because it's a perfect square. Remember, the square root wants to undo something squared. So I have a 5 squared in there. So those 5's now can work together and break out of jail. But remember, only one of them can come out. Alright? And the other guy goes into hiding or maybe just doesn't make it. So we have 5 square roots of 3. There's nothing else I can do. Over here, again, we're looking for perfect squares that will go in there. This is another example of 25 being useful because now I have 25 times what? Well, 5. If you didn't know that, 125 divided by 5, you might have to do it by hand. 2, 10, there's 2 left over. Bring down the 5. I really hope that you guys have learned this when you're in elementary school. If not, that's just not right. You should have learned that in elementary school. I'll be working my best to help you get over that as soon as possible. Now again, this is what index on this jail? Index is 2. So even though I have 5 buddies who are all the same, only 2 of them can get out at a time. So even if I have 3, only 2 of them can make it. So now I'm going to get 5 times the square root of 5, and that would be my answer. What happens if I have variables? It works the exact same way. Look for perfect squares. Is 16 a perfect square? It sure is. 4 times 4 times a times a 3 times. And of course, you're looking for pairs of 2 because the index on this radical is 2. So let's highlight. I have a pair of 4's that I can take out, and I have a pair of a's. Notice the third a gets left behind. So now I have a 4 that gets pulled out, and I have a that gets pulled out. And what do I do with those? Multiply them. Square root of what's left inside? Just the a. So I have 4a times the square root of a. And that would be my answer. Alright, what about this one? Again, I'm looking for perfect squares. Pairs of 2 guys that have the same base. Or gals that have the same base. So I'm looking for pairs. Now notice I have several pairs that will work. I have x's, and look how many y's I have. I have 5, so I can have 2 groups of y's. When that happens, then I pull out one x, and I'm going to pull out 2 y's. So I had 2 groups that could work together. There's only one y that got left behind. X, y squared, y. Okay? We can have higher roots. So for instance, a third root of 80. Now I'm going to pause this. Show you how I simplify these. You'll have to pause the video and copy these down. I have a 15-minute limit. Have a good weekend.